Now I'm going to talk about armature feedback. Now that's the ability of our system to control locos to a very slow speed. So that is set with parameter 200, and the values are from 1 to 20, where 1 is low gain and 20 is high gain. We normally send them out with a gain of about 5, but it will vary. The optimum will vary from one loco to the next. So let's demonstrate this. If I put in a low value, for example, if I put in 200, beep 2, for example, so that's low gain on the armature feedback. If I start the loco moving, it starts off at that kind of speed when it picks up and gets going, and I'll just reverse it. And so it doesn't, it's a good slow speed, but it's not as good as it could be. Now, if I set the armature feedback to a higher value, let's put in, I don't know, let's put in 18, 20, 200, sorry, 20, 200, and value 18. So that's high again. Now this means I will be able to drive the loco much slower. For example, you can get, really good creep speed indeed. And that's because the armature feedback is compensating for any losses that are going on. And it wouldn't matter if you put 3 coaches on the back of that, it would still carry on in that good slow speed there. If the gain's too high, it might start jittering. This loco doesn't, but a small tank engine might. I think an optimum value for this loco would be around about 12, something like that. So that's the armature feedback working well. So you need to experiment with the different locos as to where the optimum setting would be. But if you had a layout, for example, with a intercity loco like this and a little tank engine, you'd probably want to set the value 200 somewhere between the optimum of the two. So it just helps you achieve really excellent, in fact, outstanding low speed control, which has always been a bit of a holy grail with DC or with all trains. So we've achieved that through the excellence of the electronics, thanks to my wonderful designer, Peter Jones.